Math 2414, Trigonometric Substitutions, Video 10, Summary of all trig substitution techniques. Before I summarize everything that we've seen so far, I do want to comment that we've only seen 3 trig substitutions, basically sine, tangent, and secant. If you're wondering what about cosine, cotangent, and cosecant, honestly, anytime you can use sine, you can use cosine. Anytime you can use tangent, you can use cotangent. And anytime you can use secant, you can use cosecant. Why? Because their Pythagorean identities have the same structure, and it allows us to collapse the addition and subtraction problems down to single terms. Why do we focus on sine, tangent, and secant? That's easy. Their derivatives are all positive. When we integrated something containing the square root of a squared minus x squared, the trig substitution was x equals a sine theta. And remember, the trig identity that we were trying to take advantage of was 1 minus sine squared theta is equal to cosine squared theta, because structurally, this subtraction problem and this one have constants on the left and variables on the right. That is the catalyst for the substitution. For the square root of x squared plus a squared, our trig substitution was x equals a tangent theta. And again, the reason for that was because of the identity tangent squared theta plus 1 is equal to secant squared theta. It allows us to collapse the addition problem to a single term. And when we're integrating something containing the square root of x squared minus a squared, our trig substitution was x equals a secant theta. The tangent one is easy to remember. It's the only one involving a plus. The sine and secant are easy to mix up. And again, the way that I keep them sorted out is remembering that I want a trig identity that has a subtraction problem that is structurally like this one, namely variable on the left, constant on the right. And that trig identity is secant squared theta minus 1 equal to tangent squared theta. I also want to summarize the substitutions if the x squareds had numbers in front. So in this page, I have the exact same thing, and they don't look like the exact same things unless I erased all the b squareds. Now it's the exact same thing. In fact, maybe I should leave the b squares off and show you how to build these from the ones that you know. Now this is assuming that you know, and I didn't write trig substitution over here. Now, of course, building these is assuming that you know the trig subs from the previous page. So let's just write them down real quick. X equals a sine theta, x equals a tangent theta, and x equals a secant theta. In fact, this is a real easy something to change. If there is a squared number in front of the x, then whatever its square root is goes under the a in every case. The hardest part about this one is remembering what order to put the fraction in. But if you think about what would happen if you made the substitution, it makes sense. For example, if I were to grab this, put it here, then the b would get squared, cancel with that, leaving the a squared in front of the sine to be factored out. So really, the best way to remember what goes on top and bottom is that you want the thing on the bottom to cancel the number in front of the x. All right, I know this was a bumpy ride, but like I said, I truly believe that we just did the hardest part of this class. That is my opinion. You may disagree as we go through the course, but I've taught this course enough to know that the beginning is rough, and then it eases up a little after.